Hey guys, Joe back at it once again with some A-level further maths topics, and today we are talking about the Newton-Raphson method, and this is going to be the final part of 3 of the numerical methods sort of section of the FP1 unit, and it's the end of the FP1 unit overall. And FP2 will be coming, whether that'll be in a couple of days time like every other lesson, or whether it'll be a little bit longer. Don't worry, it will be coming eventually. I will be starting uni very, very soon, so time is of the essence, as they say. So the learning objective today is to understand how to show that there's a presence of a root between two values using the Newton-Raphson method. So we know that we can find an approximation of the root of an equation using interval bisection and linear interpolation, and those were the last 2 lessons, so go check them out if you haven't seen them. Another method for finding an approximate root is the Newton-Raphson method. This is conducted through the use of the function and the derivative of the function. However, it must be noted that this process may not always give a better approximation and could in fact take you further away from the root, so just bear that in mind when you're doing this. This is the formula for the Newton-Raphson method. So xn plus 1 equals xn minus the f of xn over f dash of xn. So it's your putting it through the function minus the normal over the derivative. That's how I remember it. So here's an example. Show that there's a root of x to the 4 minus 3x squared plus 5x minus 5 in the interval minus 3 minus 2. So if you put minus 3 into the function, you get 34. If you put minus 2 in, you get minus 11. Change of sign implies that there's a root between the interval of minus 3 and minus 2. We've been doing this time and time again over the last few lessons. So the next part of the question, because it's very, very much layered in edXL, and it leads you into the next part nicely. So find f dash of x, nice 1 marker here. Power to the front, knock 1 off the power. Remember, f dash of x is the derivative, which is dy by dx, so power to the front, knock 1 off the power, so you end up with that. And this is the third part of the question, starting with x0 equals minus 1, so minus 2, so that's just your first value. Find the next 3 approximations to the root of f of x equals 0, given answers to 5 decimal places, so you know you're not going to get nice answers here. So remember, that's the formula for Newton-Raphson, so it's n plus 1 equals xn minus f x of n over f dash x of n. So in this case, we're just going to replace the f of x with the function, so you end up with that. So x1 would be x0, because remember it's xn plus 1, so x1 is 0 plus 1, so n here is a 0, and we've been told what x0 is up here. So putting an x0 everywhere there, and then putting in a minus 2, and you end up with that, and you're thinking, hold on, there must be an easier way to do this. But eventually you get x1 equals minus 2.73333, and that's to 5 dp. But it is best to use the ANS facility on your calculator, so you might find it nice just to put minus 2 into your calculator and press equals, and then using the ANS facility after that. Sorry about that little noise. I usually record me videos in bulk, and for some reason today it's been really slow, so we're getting confirmation through way into the next episode. So that's what the little noise was. So that, as you can see, makes it a lot easier on the eye, because it's ants minus ants to the 4 minus 3 ants squared plus 5 ants minus 5 over 4 ants cubed minus 6 ants plus 5. And if you press that, however many times you want the approximation, so for the x1 you just press it once, for x2 you press it twice, and you just press it again basically. So x1 is that, and then we'll press it again to get that, x2, and then we'll press it again to get that x3, and there's your 3 answers right there. So second one, show that there's a root of 4 root x plus 9 equals 10 over x squared in the interval that. And yet again, that should be no, it doesn't. Never mind, because we can take it over the other side and it's a minus. So you end up with that. Putting a 0.5 through, you get minus 28.17. Putting a 1 through, you get 3. Change of sign implies root in between 0.5 and 1. Next part, find f dash of x. So you want them all in power form, and that is f dash of x. So, you know, check it out. Check that I've done the right maths. Starting with x0 equals 1, find the next 3 approximations to the root of f of x equals 0, given answers to 5dp. So it's exactly the same as the last question. There's the Newton-Raphson. So to find the next one, that just looks horrendous. It really does. But remember, you could do all of that, but it's best to use the ANS facility on our calculators. So type in 1 and press equals. By the way, that's just a nicer way to write f dash of x. It's animated a bit funny, but that, although it still looks awful, looks a lot better than that, in my opinion. And remember, just press it as many times as you want. So x1 would be that. Note it down, press it again. x2 equals that. Note that down, press it again, and you get that. So, unfortunately, I can't really take you through the maths. It's all calculator work, which is the unfortunate thing, but there's a little bit of calculus in this as well, just to keep your appetite firmly wetted, firmly moist, shall we say. I think that's going to be it. Yep. So that's that. That is FP1. All of it taught. The only thing I haven't taught is matrices, and that's because it comes up in GCSE Further Maths, and there's plenty of videos already online about that. But if you really want us to do a video on matrices, of course I'll do it. So hopefully you've found all the videos helpful in the FP1 playlist. Make sure you leave a like if you did, and it just helps me know that I'm doing a decent job. Obviously I'm not a qualified teacher, so I might not be the best teacher in the world. And I'm just doing this for fun, ultimately. Leave your comments down below. Any questions, I will try my best to answer. And I'll see you guys next time, and we'll be starting FP2. Most likely, I might dip into mechanics first. I really haven't decided yet. We'll see what's what. But, yeah, FP2 will be starting with some inequalities. And it does sound pretty easy, and it's fairly easy, thinking about it. So I'll stop waffling on. Hope you guys are having a wonderful day. Thanks for watching, and goodbye.